Well, I hope you've seen my written solutions to this problem, and I give you a logical explanation as to why it can't possibly travel the same distance in the second half of that travel and kind of why it needs to be that frame. But you know what? Theoretical and reality, it's always fun to do the real thing, and I certainly hope you've already got the chance to do this, or maybe you will get to do this in your physics course, and that's doing some recording. So what I've got here is I've got just an iPhone camera, and I've set it up on a tripod. I'm trying to reduce the amount of parallax, so I'm trying to get it as at the right level and center to that ramp. You also want to make as long a distance as you can. The more zoomed out, the more you're using the wide angle of a camera, the more lens distortion you get, and the less reality is represented on the screen. Things get distorted. So try and get a bit of a distance. Always good to have it further away and zoomed in. And you want to take lots of frames per second. Now, both of those things mean that you want to have as much light as possible on your subject, because the more light, the shorter the exposure time can be, and then the less blurry each of those frames are. And if you want to go through frame by frame in that video to take some measurements, it's always good to have it nice and clear. And so I'm just going to put it up on this glass ramp. Now, you might be thinking he's chosen a glass ramp because it reduces friction. But actually, no. If you think about how a wheel and a tire works, the tire that's in contact with the road is not sliding past the road. It's that friction force between the tire and the road is not something that's slowing the car down, unless, of course, you're applying the brakes, in which case then the tires are trying to push forwards on the road and using that coefficient of static friction to generate a force forwards on the road and therefore backwards on the car. Or alternatively, if you've got the throttle open and you're taking off from a set of lights, you're using it the other way and the tires are pushing backwards on the road and the road is pushing forwards on you. But in terms of just rolling along, the friction between the tires and the road is not actually a slowing down force. Anyway, I chose glass because it's nice and flat and level, and I wanted a nice consistent roll. So let's do some of those recordings and we can have a look at them. So record the video in slow-mo if you can using your phone, lots of light, and then click on edit the video. You can zoom back in again so you can still see what's going on. And when you start to scrub that timeline, you'll see that the time comes up in this lovely 2 decimal places. So you've got a really accurate measurement of timing. And I'm going to take 22.01 as my start time. I'm going to find the end time here. Yep, 22.79. Work out what that duration is, halve that duration, add it to my starting time, and that tells me that 22.40 is exactly halfway through the time it takes to go down that ramp. And you can quite clearly see that it can't be anywhere near the halfway point. If you find this kind of thing helpful, over here there's a whole database of these kind of questions searchable by Science Extension, Investigating Science and Physics, and by module. And if you're a teacher looking for really good quality trial exams and course exams, then they can be found here.